Hello, in this episode, we'll go over an example of SHAP value method for finance example, that's predicting Boston housing prices, which we have done in the supervised learning. Now we'll see how each feature explains towards the price. Okay, so and eventually we'll get some plots like this. Let's go to the code. So this is Boston housing data we already have covered before. And what we need is this Shapley value package. Okay. I think it's almost done downloading. Okay. So now we'll use the libraries mostly with the Panda NumPy, but also the TensorFlow, and then the Shapley value packages. Okay. And let's upload the Boston housing data. It's available from Kaggle. I downloaded on my local computer. Here. And let's put it in, read it into data frame, Panda data frame. So, and here's the standard thing. I'm going to take the median value as the Y variable, and we split the test and train data. And the rest of the variable other than the median value will be the X variables, the features. We standardize it by using the training data X variables, mean and standard deviation. So we scale it and convert it to NumPy. This is all what we have done before, so I'll be quick. Then we can define a network, neural network. Let's just have input and then 10 node middle layer and then one output, which is a linear activation because it's a price. It's not a 0, 1 variable, it's actually a price. So let's have a linear activation at the output. So that's a one node because its prediction is just one variable, which is the Boston median housing prices. Okay, let's define the network and train the neural network using the X and Y variables. Okay, and you can check the accuracy and mean in terms of mean absolute error. And here are the predictions, the Y variable from the model predictions. How are the predictions looking like in a scatter plot between the actual housing price value and the predicted? Well, it's a little bit scattered, but sort of falling along the 45-degree line, which means the actual and the predicted are reasonably well matching in most cases. So let's go to Shapley value method. Okay. So again, you could use the background if the data is very large, the training data is very large, and having every sub-combination of the groups you can form from the feature variable can be potentially large in an image processing, but here it's very small. So we could just use the Shapley value using just the X-trained data. Okay. But actually comparing the Shapley values here, I'm just going to limit my sample to be 100. Okay. It will still take a while to compute, so let's come back when it's done. Okay, it's done computing the Shapley value. So let's see. Originally, the dimension was one channel of 102 by 13. So the Shapley value here, it's 102 by 13. So there are 13 characteristics. And the influence in terms of the absolute, so negative or positive, how large are the influences? Here, the RM variable turns out to be very large influence. What is the RM variable? Average number of rooms per dwelling. So that impacts a lot for prices. Another one we can see that's important is ZN, which is proportion of residential land zone for the lots over 25,000 square feet. So you can see that by doing the Shapley value method, you can see which, although the neural network is like a black box model, you can sort of get something like a regression coefficient, isn't it? Some large influence, small influences. And if you like the signed version of it, you can here have a plot type of a dot rather than a bar, and it will show you relative impact of the model for each dot. So each dot is like an observation, isn't it? And then for each observation, it represents for each feature where do they lie for each feature. Okay, but collectively you get a good idea of how overall the observations, what are the forces driving positive or negative towards making a prediction. Okay, so let's look at the sixth observation of the price. And then for individually, you can look at the what we call a waterfall plot. And for that fifth, well, housing observation, the value was 21.623. Okay? And here the very large negative forces and some positive forces here. And you can see for each observation, how each feature impacted in making this prediction, this expected value. Likewise, you can look at the force plot, which is very similar to this. What are the positive forces? What are the negative forces? Of course, you can do it for other observations, like the fifth observation. You can see a little different prediction, isn't it? And you can do it for multiple. So not just one Shapley value like this, but you can look for all 100 of them, for example. So here, I guess we are vertically flipping, 90-degree flipping it. And you can see here for each observation, so there are 100 observations, and here the Shapley value is stacked vertically instead of horizontal. So this is another way of seeing Shapley value methods and how it influences. Okay, so this is an example of how Shapley value method to explain the deep neural network, what it's doing, how important are each features, and show it as an example. Thank you for watching this episode.